Hello everyone, welcome to my channel. Today we will be discussing about how to recode our land use land cover map that we have generated using Google Earth Engine. Today we'll be demonstrating on Arc Gis PRO software how to recode. Next we'll also be demonstrating the same in AirTAS, but for the time being, let's jump into the exercise. So first open the LULC map. Here we have got 9 classes. So let's see, why do we need recoding? First of all, if some classes gets misclassified into some other classes, then we can bring it back to its original form or original class that it should be as per the base map. Here it is the world imagery Google Earth map that is a mosaic of a lot of satellites. So using that we will be recoding. First we'll be rendering the correct form of color to our LULC. Then we will start our recoding. So we have rendered our desired symbology as per the conventional signs and symbols. We have rendered the accepted color norm, that is yellow showing agriculture, dark green showing forested areas, and so forth. So we see there is a stream, a river stream, but the sandy deposits have been misclassified as urban areas, which is shown in red. Since the sand and the urban areas have similar type of spectral signature, therefore this misclassification has occurred. Now, to correct the misclassification, we will be doing recoding. So now that we have understood the logic behind this, we will be first polygonizing, that is changing raster data into polygon in the first step. The LULC that was generated, mind you, was generated as a raster layer. So, and it was downloaded from Google Earth Engine platform, having an accuracy of 93% kappa approximately. So it is a quite high percentage. Even then, there has been areas where pixels were misclassified. So we will be polygonizing the raster data. Here we have generated our polygon. Now one thing that we need to keep in mind, here we have not simplified the polygons, neither we have made a multi-part polygon. You can do the needful if you wish to have those features in your polygon layer, but for my analysis these two were not required, because I wanted my pixelated cells to be kept intact even in the polygon feature as it was in the raster, and I did not make it multi-part because I wanted to work on each and every small polygons bit by bit, because if I had multi-parted that, it would have been wrong in my case. So you see, we will be changing the red pixels that in reality represents a sandy deposit in the river basin, but it has rendered urban class or urban feature as a misclassification. So we will be first using select option to digitize or pick up the pixels of those particular regions only. After we have done that, also I need to mention that selection you can do using several options. There is lasso, there is polygon, a rectangle. I have chosen lasso for my recoding, but you can choose any of the given choices. Now that we have selected our region using lasso select, we will be going to select by attributes. You see all the pixels that comes within close proximity first and sometimes beyond have been selected. Now to make the selection appropriate to the lasso selection polygon that we have, the region that we have taken, only that much, we need to go to select by attributes. Within select by attributes, we need to select the base layer that will be our LULC that has been polygonized. Then from that selection, we need to select subset of the current selection and give the clause. Here the clause would be like I want to change my pixels which are red representing urban into sand. So first grid type or grid code needs to be urban. So this within this lasso selection, whatever has is urban will be selected, and then we can change from attribute that all the pixels or all the small polygons that represent urban within our current selection needs to be changed into something else of a feature class, like sand in my case. So here it is changed into sand class. Be very sure while applying the clause, which will highlight only the portion that you need to change. You can do with select by attributes as I just demonstrated right now, or you can just select each and every individual small polygons that has formed by continuously pressing shift. you can do that as well. That will also give you the desired number of small polygons that you can convert into other classes by following the same process, like going to attributes and selecting all the polygons by their ID number and changing its class from what it was to what you want it to be. Also, if you feel that the polygon that has formed due to polygonizing our raster LULC layer is a bit too large and you want to split it into smaller chunks of polygon so that you can work properly, thus rendering a higher accuracy to the already made LULC, you can use tools like split as well. That would be under the edit toolbar. Like for example, here in my image, the dense vegetative region is one big chunk of a polygon. So if I want to change some of the feature or some of the location where urban vegetation is not that dense, I can split it into smaller parts and work on those smaller chunks. Also, if you want to make multi-part, you can use the merge option as well.